Unfortunately, I didn't bring my book home, so I'm just going to do my best to explain this, and sorry for the terrible lighting and all that. But so say you have a table, and here you have methods, and these are the things that you use to measure it. Because when you're using percent error and you're using accepted absolute error, it's trying to measure your experiment against experiments that people already did and said that was accepted. So one thing that you guys will all probably understand is the speed of light. The speed of light always has an accepted value. We're going to measure against it. So say we know that the speed of light is 299,744,458 meters per second, okay? That's the speed of light. This is the accepted value, okay? These would always be given to you. These are values that you could find in a book or some kind of encyclopedia of accepted values. Now, you're going to use this and you're going to measure using some experiment in a lab, and you're going to get some values, and you want to see if your values compared to the speed of light, and if you can try to be accurate and get as close to this number as possible. The closer you can get to this number shows the precision, right, of your instrument, and how precise it can get is a little different than accuracy. Precise means it's consistent, okay, even if it's a bad number. Accurate is how close it is to this actual number, okay? So if I had a bunch of methods, okay, so I did an electrical method, I used a laser, all these different kinds of methods to see how fast the speed of light is going. I'm going to see how close I can get with my averages to the accepted value of the speed of light. So if my value for electrical was, say, 299,744,333, then I am going to use this as my measured value, okay? Because that's the value that I got. This is the one that we know based off of things that have been accepted, based on scientists doing this over and over and over and saying, okay, this is what the speed of light is at all times. So our method with electrical gave us this number, so we're going to use that as the measured and this as the accepted. So if it asks me for absolute error, that's how I'm going to use these values. If I'm going to ask for percent error, I am going to do that measured minus the accepted, and I'm going to do a step further and divide it again by the accepted to give myself a percent. So what you could also say is a percent error is just absolute error divided by the accepted value times 100%. Okay? The percent error is saying how much does it deviate by a percent, and this is saying how much does it deviate from the accepted value by some number. Now, if an instrument is more precise, it's going to get a better and more accurate value. If we have this table, okay, and it shows all of our averages, and it asks you which method was the most accurate, you would choose the number that's as close as possible to your accepted value of the speed of light. If you have any more questions, just email me.